Hello students, in this video we are going to solve some typical examples on projectile motion. So read the statement. A cricket ball is shot by a batsman from a height of 2 meters at an angle of 30 degrees with the horizontal with a velocity of 20 meters per second, caught by a fielder at a height of 0.8 meters from the ground. Determine the distance between the batsman and the fielder. So let us first show the positions of the ball when it is hit by a batsman and when it is caught by a fielder. So it is hit from a height of 2 meters from the ground. Let us say that is point A, and it is caught by a fielder at a height of 0.8 meters from the ground. Say that is point B. Let U be the initial velocity, which is given as 20 meters per second, and at an angle alpha which is 30 degrees with the horizontal. Now we have to find out the distance between the batsman and the fielder. That is the distance between the points A and B. Let us say X. Is it clear? Now, what is the vertical displacement from point A to B? The vertical displacement from point A to B, it is downward displacement. So it is 2 meters minus 0.8. So 2 minus 0.8, that is 1.2 meters. But it is downward displacement. Now we can solve this example by two methods. You can consider the horizontal motion and vertical motion separately, being you know the vertical displacement. By considering the vertical motion of the ball from A to B, you can find out the time, and using the horizontal motion you can find out the distance. That is from first principles. Or directly you can use the projectile equation. The projectile equation is the combination of horizontal and vertical motion. So let us solve this by both the methods. So we have the horizontal displacement x to be found, vertical displacement from A to B. We are considering the motion of ball from point A to B. I am not saying horizontal motion or vertical motion. It is projectile motion from point A to B. So y is equal to minus 1.2 meters. Why minus? Because it is downward displacement from A to B. It is downward displacement. Initial velocity is 20 meters per second. Angle of projection alpha is 30 degrees. So what is the projectile equation? Y is equal to x tan alpha minus gx square upon 2 u square cos square alpha. So here in this expression there are total 4 variables are there: x, y, u, alpha. Out of these 4, if any 3 are known, the fourth one you can find out directly by using this expression. So y is equal to minus 1.2 is equal to x tan 30 minus 9.81 into x square upon 2 into 20 square into cos square 30. So simplifying this, you get a quadratic equation: x square minus 35.39x minus 73.62 is equal to 0. So please find out the value of x. Do the calculations. So solving this quadratic equation, you get x is equal to 37.36 meters. That is the required distance. Right? Directly you can find out using projectile equation. If you want to solve from the first principles, so we know the vertical displacement. So let us consider vertical motion. Vertical motion of projectile from point A to B. Vertical motion is under gravity, and we can use the equation y is equal to ut plus half at square. Remember, a is equal to minus g. So what is the vertical displacement? Y is the vertical displacement from A to B, minus 1.2. U is the vertical component of initial velocity. Yes, horizontal component here. It is 20 cos 30. The vertical component u sin alpha, that is 20 sin 30. That will be 10, right? Into t plus half into a is minus 9.81 into t square. So solving this equation, you will get time of flight t is equal to 2.15 seconds. Now consider horizontal motion. Horizontal motion of projectile from point A to B. Horizontal motion is uniform motion. Acceleration is 0. You have displacement is equal to velocity into time. So what is the horizontal displacement from A to B? It is x. U is the horizontal component of velocity, 20 cos 30. Into t we have 2.15. So you get x is equal to 37.24 meters. So the small difference is there in the rounding the digits. Is it clear? So either you can solve from first principles by considering the two motions separately, or you can use the projectile equation directly. Okay, thank you.